Hello and welcome to T2 Day 28 of Honors Precalculus. Today we're going to talk about a pretty interesting type of graph from polar land called rose curves. And these are going to be functions that are of the form r equals a cosine n theta or r equals a sine n theta, where n is greater than 1 and a is also a constant. Note if n is 1, we have a circle. So let's analyze the graph here. I'm going to tell you a few of these things and we're going to figure out a couple of them. So the domain here, domain means what can we plug in here? We can plug in anything because sine is defined for all real numbers. So the domain here is actually all real numbers. The range, you have to think about what's the biggest and what's the smallest output you can get. Well, the sign of anything has to be less than 1 or greater than -1. So it doesn't matter what you plug in, but then you're going to have the 3 on the outside. So the range here is actually going to go from -3 all the way to 3, because the smallest sign can be is -1, and the biggest thing it can be is 1. Multiply times 3, and you get -3 to 3. Now sine is defined everywhere, so sine of 2 theta is, so 3 sine 2 theta is defined everywhere. So it's continuous everywhere. Nice. How is it bounded? Well, we know it's bounded above by 3 and below by -3. So you can say it's bounded above by 3 and below by -3. And keep in mind these are r values. R equals that and r equals that. So it's bounded above by r equals -3. Above is distance from the origin, the pole. And what about the number of petals? This I'm just going to tell you. The number of petals in this case, the number of petals on this flower, they're called rose functions because they look like flowers, rose curves. There are 4 petals. So where will the mins and maxes occur here? Or excuse me, where will all the maximum values of r occur? Remember, r is equal to 3 sine of 2 theta. So the question is, where will all the maximum values of r occur? That's the distance away from the origin. So the max distance for this is going to be 3. It's going to be where are all the points where it's 3 away? Well, that's going to happen when sine of 2 theta is either equal to 1 or sine of 2 theta is equal to -1. So when you do sine inverse here, you get 2 theta is equal to sine inverse of 1. And that happens at pi over 2 plus a rotation of 2 pi k. And this one right here is going to be sine inverse of -1. 2 theta is equal to that. So the sine inverse of this is going to be 3 pi over 2 plus 2 pi k. So what you end up with is 2 theta is either equal to pi over 2 plus 2 pi k, or theta is equal to 3 pi over 2 plus 2 pi k. Divide by 2 and you end up with pi over 4 plus pi k, or theta is equal to 3 pi over 4 plus pi k. So when you graph this, what does it actually look like? When you graph this, what does it look like and how do you go about doing it? Well, the first thing you can do is you can graph r here and theta here. And if you do that for this function here, this is what you end up with. So when you graph it out, you end up with a graph that looks like this, where r is here and the input theta is on the x-axis. So how do you plot these points on a polar graph? Well, it starts at the origin right here, and then here at that point when it's pi over 4, the output for the r value is 3. So that actually is going to be right here. And if you graph this out, it looks like this. It travels along, it curves, and then it comes back, because you know it comes back. All of these things, all of these curves are going to come out to be the same petal shape. So when you go down here at -3 at 3 pi over 4, it actually goes down like this. So it goes down to here like this, and then every time it goes out, it goes back in. All these petals are going to be exactly the same curvature. So then it's back here at pi 0, and then you know it's going to be at 5 pi over 4, it's going to be 3. So what's that going to do? It's going to be out here. Excuse me, 5 pi over 4 is actually right here. So it's going to go like this, and then like this, so there, then back up, and then it's going to go to here, and then back down. And then after this, it's going to repeat itself. So if you plot the points, that's the shape you end up with. So one thing you can also list out here if you really want to is, this with this function, you know that it's going to be, the pole is 0, 0. It's going to be back there at 0 pi over 2, and it's going to be back there at 0 pi, for example. And it's going to be out the tips right here, the tips here. This is where it's furthest away. Those 4 tips One of them is going to be at negative 3 pi over 4. Another one's going to be at 3 comma 5 over 4. And another one's going to be at negative 3 comma 7 pi over 4. And the first one right there is going to be at pi over 4, 3. And then they repeat. So if you didn't have a calculator and you're going to do this by hand for this function r equals 4 cosine theta, I'd give you a piece of graph paper like this, Cartesian, and you need to graph the function. So starting at 0, plug in 0, cosine of 0 is 1, so it's going to start up here at 0, 4, right up here. So when you graph this out, you end up with one rotation that kind of looks like this, and then it keeps going. Keep in mind you have to do this very carefully. This is going to be pi over 6 right here. And then you end up with each division is such. So it's pi over 6, 2 pi over 6, 3 pi over 6, pi over 2 right there. So you have to be really, really careful about this. So it keeps on repeating, and you end up with this curve right here. So when you plot these points, you start at the origin right here. So, excuse me, not at the origin. You know that at 0, it's going to be out at 4 right here. It's going to be 4. This point right here correlates to that point. There's point A and there's point A. So what happens, it stays positive, but it goes towards the origin. It ends up doing like this, like that. And then what does it do? So you're going to make all these petals. It's actually going to keep going down to this right here. This is pi over 3 right here, so pi over 3, but that happens to be negative 4 for the r value, so it's flipped. And then it goes back like this. And then what does it do? It goes up all the way to here, which is the point 4 comma 4 pi over 6. So then it's going to go up like this. I'm just following these points. I'm following the points on the left, and then it goes back. Sorry, the arrows are going to go up and then back down like this. So it's smooth. So what does the path look like on this? The path would go like this, and then it goes like this, and then it comes back. And then it would do the last part here and go down like that. So that's the order of creation there. So in this case, the number of petals is 3. There are 3 petals here. So one thing you can say is you're at the tips. You're at the tip of the petals, these 3 points, at pi over 3 times n. It's pi over 3 in terms of getting to that one, and then getting to there, and then getting to there, 3 of them. And then you can say you're back at the pole. You're back at the pole at pi over 6 plus pi over 3n. And then you can say the number of petals is 3. That's the number of petals. So how many petals are there for each of these right here? So if you have, using Desmos, you can test this out, and we'll do more of this in class. We can graph this function. Let n be odd integers. How many petals are there? It equals n. That's the number of petals. And let n be an even integer. How many petals are there? 2n. So when it's even, when n is even, it's 2n, and when n is odd, it's equal to n. Just 2n. So just remember the keys to graphing these is you can graph it in Cartesian coordinates first, and then you can plot a to that point, and then plot every other point as such. So for example, pi over 6 right there is back at the origin, and then it keeps going down. And then here, you can call this point B if you wanted to. That point is going to be right there. So plot them one at a time, and you end up with these cool petals.